In a parallel world. The war did not end in 1945 and country was divided. After the war, the Sakura Empire was peacornly born. The Sakura Empire, smaller in scale, but more powerful than the pre-war Japanese Empire. A much more troublesome nation than the Japanese Empire. From today I'll explain to you all. I don't know any difficult words, so it might be a little strange. I'll add a little explanation to the previous video. We talked about transposing matrices. Now let's think about a one-row matrix. What's the difference between putting it vertically and horizontally? Maybe it's the same. But there are problems when doing the calculations. Since the weight is 13 rows and h columns, x must be 1 row and 13 columns in order to be calculated. In the last video, I wrote x vertically. But this is because of space limitation. I didn't mean transposing x. Last time I suddenly used the term backpropagation. The flow, from right to left, indicated by the red arrow. Why do we consider backpropagation? Frankly, I don't understand. According to the book, this is to reduce the load on the computer. Let's look at this picture. The final output L is called the loss function, which is the error between the answer the computer arrives at and the correct answer. The goal of the training phase is to find the parameters, weights, and biases that minimize this error. The error L being minimal means that the loss function L has a minimum value. How do you find the minimum of a function? Use differentiation. Backpropagation is differentiation. In other words, gradient dw is the gradient of the loss function L with respect to the weight w. Let's calculate dw. Let's look at the last part of this picture. The output of the backpropagation, dout, is obtained by multiplying the input value, 1, of the backpropagation by the partial differentiation of the output of the forward propagation, L, with respect to the input of the forward propagation, out. Let's find dw in the same way. The output of the backpropagation, dw, is obtained by multiplying the input of the backpropagation, dout, by the partial differentiation of the output of the forward propagation, out, with respect to the input of the forward propagation, w. The output of forward of propagation of the affine transform is obtained by multiplying the input x by the weight w, and then adding the bias b. The output of the forward propagation, out, is a one-row each columns matrix. Comparing it with the source code. We should take a closer look at this part. Differentiate a vector with respect to a matrix. How can you differentiate a vector with respect to a matrix?
Are you talking about affine transformation? How about partially differentiate each element of the vector out with respect to each element of the matrix W? Not sure, but maybe it will be a tensor.
Tensor. What's tensor?
Tensor. Many sheets of paper are fluffy. Each piece holds information as a matrix.
桜帝国国営ラジオです。帝国新民の皆様、日の入りをお知らせします。以降、外出はお控えください。